The whole point of this lesson is going to be just to determine if a relation is a function. So let's stop and think about this. On our last two lessons, we were dealing with what are relations, trying to find the range if given the domain, that sort of thing. And we know that relations are just a set of ordered pairs. So now we're going to start giving you these sets of ordered pairs, these relations, and we're asking you, are they functions? Some of them are, which means that some of them are not. Now, here's the basic definition of how to tell if a relation is a function. It is for each x value, that would be our domain, right? We're talking about our domain there. For each x value, there is only one unique y value. And we'll talk a little bit about what unique means. I don't want us to get too caught up in that, but basically it's some sort of relationship between the x values and the y values. So let's go ahead and take a look at an example here. Here you see the relation given to us, and it's three ordered pairs, and we're saying this is not a function. Why? Well, let's look at our x values. This is a 2, this is a 2, and this is a 3. Now, basically, because these repeated, we have to look closer. So when your x values repeat, you look closer at them and you go, what was its y value? Since this x repeated with this x over here, I know that this x got me a y value of 4, but this x got me a different y value, it got me a 5. Because this is a different y value than this 4 here, it's not a function. Why? Each x value has to have one unique y value. We're fine that the x is repeated. What I'm not okay with is that when the x is repeated, it didn't get the same y value. See, this is an ordered pair. It's 2, 4. This is an ordered pair. It's 2, 5. Because the y values differed, that's why I'm saying it's not a function. Each x value has to have a unique y value. Now 2 has a y value of 4, but it also has a y value of 5. So you see, the y value is not unique to the 2. It's not tied in. We need it to be, hey, if I have a 2, it's always going to be a 4. Or if I have a 2, it's always going to be a 5. I can't have this, I've got two different values coming in there. And that causes a problem for us. It violates that definition of what a function is. So it's still a relation, it's still a set of ordered pairs, but it's not that special relationship that we call a function. Let's take a look at example 4. Let's look at our x values. That's what you always do when you start looking at these relations to see if it's a function. Let's see, I've got 1, 3, and 5. Did any of the x values repeat? No. So that means that when I look at 1 in this relation, it's got a unique y value of 2. And I know that the 2 is repeated. I don't care about that. The x values have one unique y value. When this 3 came up, it got a unique value of 2. And that means if 3 came up again, I would still get a 2. And if 3 came up again, I'd still get a 2. If I get a 5, what am I going to get? I'm going to get a 6. So each one of these x values has a very specific and special y value attached to it. So the easiest way is this. When you go through these relations, again, I've said it once and I'll say it again, look at your x values. If they do not repeat, if no x values repeat, then it is a function. If the x values do repeat, like this situation right here, quickly check their y values. If all the repeating x values have the exact same y value, it is a function. But if there's a difference, like this 5 is different than that 4, then it's not a function. So let's take a look at these three relations right here, and then we'll wrap this lesson up to let you practice some more. The first thing that I said was go take a look at all the x values. So this is a -1, -3, a 0, and a 2. Did these x values repeat? Nope. So it's a function. Each x value has one unique y value. Let's go through and look at number 2. It's -4, -2, -1, and 2. Did any of these values repeat? No. So yes, it is the function. And now let's go and take a look at our last relation here. This is a 2. This is a 3. This is a 2. Uh-oh. See that? They repeated. And this is a -6. Well, we're not going to say it's not a function yet. We want to look at the y values. This 2 got a y value of 1. This 2 got a y value of 1. Oh, okay, that's fine. We got the same y value, so yes, it's a function. If this had been a different y value over here, if it had been anything but +1 for this y value, we would have said it violated the definition of a function, and we just would have said that it is not a function. So these are all examples of relations that are functions. I'll tell you what, let's just quickly write in a fourth function here. 2, 1, 3, -4, 2, 0, and -6, -2. And what you've probably noticed is that's the exact same relation as what I showed for number 3, but where our 2's repeated, I made one subtle change. I changed the second y value. So our 2's repeated. This got me a +1. This got me a 0. Since it's not a +1, like this one was over here, it's not a function.